Hello, welcome to the Naftiko Capabilities podcast. My name's Ken Lane. I'm Chief Community Officer here at Naftiko, but you might also know me as the API Evangelist, where I've been talking about APIs, the technology, the business and politics of APIs. But now I'm building Naftiko, and we're centering our API integrations around business aligned capabilities. And so I started this podcast to talk with different folks about all the same things with APIs, integrations that people are used to from me. But we're going to be trying to steer things towards the business side of what's going on. So the format, try to keep it to about 15 minutes and talk to different folks. And most of the time I've been slicing up different conversations, different questions that I ask my guests, and then I stitch them together. We started with one on capabilities. Then I went into hypermedia and some AI and microservices. But sometimes there's conversations with folks that I have to keep, for the most part, intact. I'm still gonna stitch together, but I'm gonna have one guest. And this is one of those episodes because I talked with my friend David Biesack about JSON Schema. And if you read API Evangelist, I'm a big JSON Schema fan. And I think it's an important tool in our toolbox. And it's one of those things that are going to ground whatever we're doing. And David's approach is one that I've learned from for years. And it's really interesting. And it really reflects, I think, how JSON Schema can stabilize things. And so I sat down with David and I asked him, share how he's using JSON Schema so that we can all learn from it.
Sure. So OpenAPI kind of defined its own way of defining schemas originally when it was originally OpenAPI 1.2 and then 2.0, 3.0. With 3.1, they basically adopted the standard for JSON schema using the 2020-12 definition of JSON schema with a vocabulary that defines certain things that fit with an OpenAPI. And that was using the extensibility of JSON schema. So basically what it gives us is to reuse JSON schema as a standard, as an open standard for defining the data models for our API request bodies and response bodies, as well as using schemas for other things too, like query parameters and header parameters, et cetera. What that gives us is a standard way of defining all the data that flows in and out of our APIs, and that's really powerful. So one of the examples that we've done is I had originally written a tool very early on called our OpenAPI model gen, which basically parses through the schemas within an OpenAPI document. And within the document, you describe all your schemas for your request bodies and response bodies, et cetera. And then this model gen tool will create a schema bundle that extracts all those schemas into a single file. And that allows usability to allow tool people and test people to work with the data without having to understand the wider structure of an OpenAPI document. So for example, someone who's writing tools can create test data to test the APIs. And if they create a test request body, they can validate that in line directly by just asking to validate this schema against the schema bundle without having to understand how to pull schema bundles out of an OpenAPI document. So it facilitates understanding how the data is used within our OpenAPI documents without having to understand the complexity of OpenAPI.
The way David approaches the use of JSON schema and in relationship specifically to OpenAPI, I think is what makes JSON schema such an important specification, because it's used like that for OpenAPI, for async API, for many other specifications. So he really gets at, I think, the heart of why it's such an important tool in our toolbox. But another aspect of that I think is critical and is a really challenging and kind of issue that's a lightning rod in the space is the JSON and YAML usage around JSON schema and OpenAPI. And so I asked David to share a little bit more about what it looks like, when does he use JSON, when does he use YAML, how does that relationship fit into their development workflows?
We try to stick with YAML as much as possible because we know humans are doing the bulk of the work here. So our OpenAPI documents are authored in YAML source. These release notes that I talked about are written as YAML source because the bulk of the elements of the release notes are going to be the descriptions of what has changed and why it has changed. Mm-hmm. So we can say, okay, this API, we added this new operation and we added these new schemas, blah, blah, blah. So a lot of that is going to be just free text. And it's really awkward to write that type of stuff in JSON. It's much easier for humans to author things in YAML. But we use just the schema, I guess it's language variant of the tools that convert YAML to JSON. So there's a JS YAML open source tool that does that conversion, and it's got a JSON model, I guess, attached to that. So when we parse the YAML, it sticks to a specific JSON appropriate schema or language variant for that. So we only use those elements of YAML that are really fully compliant with JSON and not any extensions. So typically users, developers, and authors and API designers will stick with YAML, and then tools will simply just convert to JSON if they need to in order to process the data.
That's how it needs to work in my experience and in my opinion, is you got to have that balance in YAML for authorship and then JSON in build and runtime. It's another grounding and balancing aspect of using JSON schema, but just using schemas in general when it comes to defining what you're doing. It helps balance things out. But there's another interesting and kind of lightning rod and touch point with working with JSON schema that David and I talked about that I wanted to bring up is the use of refs. So $ref or references when you're referencing JSON schema within a document or outside of a document. And again, I think the way that David uses JSON schema and OpenAPI is pretty key to this and how he uses YAML and JSON together. But references are an interesting point. So I asked David, does your average developer have to be able to, wrestle with and understand references to be successful when working with these specs?
Exactly. So, one of the great benefits of OpenAPI, especially from the 3.0 standpoint, is this notion of components and the component structure within an OpenAPI document, which allows you to split up a complex API into multiple files to allow for reuse and componentization. So we have a common OpenAPI document that's shared across most of our other APIs. And the common document describes common elements that are reusable across APIs. For example, for our error response objects, we've adopted the application/problem plus JSON description from RFC 9457. And that's a standard way to describe what happens when an error or a problem occurs in an API request. We've defined JSON schemas for our problem response object for those 400 and 500 errors, as well as a reusable just API problem schema. And that goes into our common API. And then when we define specific APIs within the banking domain, for example, for accounts, transfers, transactions, payment batches, ACH, et cetera, all those different APIs that map to specific banking domains all will reuse these common schemas from common, which means designing an API is simpler because you're reusing things instead of having to copy and paste. You can just reference those. But that complexity can be a reach for people who are implementing or using the APIs, for those that are doing testing or development. Mm-hmm. So we have another tool, which we've actually open source, called API Ref Resolver, which will, and there's other different open source tools that do the same thing for bundling an OpenAPI document that's split across multiple documents, merge them into one document such that there are no external references. Everything becomes self-contained within that document. Our tool was written kind of before some of the others showed up, and it was really designed to support this notion of the component model. So it understands that structure. It works for OpenAPI as well as Async API, but it eliminates a lot of that complexity of dealing with our multiple APIs split across lots of different files and stuff. So it gives everybody kind of the built-in or the freestanding API definition without all these external references. It simplifies a lot of use cases. And so that includes our use of schemas and things like that.
working with schemas as David recommends and does, the unbundling and bundling and referencing and being able to work with many different schemas within an open API or outside of an open API, across open APIs, is how we deal with the complexity and reduce that complexity down to a manageable chunk, but keep things disconnected and potentially federated and distributed, allowing us to mix and match and use them in different ways. And if you think about it, this is one of the biggest problems we're encountering with MCP and building MCP servers is, what is that context window? How do you need to do that? But one downside of this is you end up, having a sprawling landscape of these schemas. And so I asked David, how do you approach and manage schema discovery when it comes to this work?
Yeah. So within our pipeline, we build all of our APIs from source. We have a source file that's managed in Git. Then we run several tools that pre-process the source to create the ultimate or the generated open API that's fully resolved and explains everything and embeds other things. We have some open API generation itself. So we augment the API through this pipeline, and it gives us our generated or complete open API definition. And then that's what gets published into our developer portal. It gets published into our internal software repositories for other people to consume. So if the backend team is building the implementation of an API, they can do code generation off of that to build data objects and data transfer objects, et cetera, on the back end and implement the rest of the API using code that's generated off the open API source. But again, when they get to that point of generating code off the open API, they don't have to worry about any of these external refs, everything is standalone and self-contained. So it makes their job much simpler.
There's that context window again. You're bundling up a specific set of APIs, paths, and schemas that are all interwoven and referenced, and you're producing that so you can generate code from it. You can generate MCP servers from it. You can generate agent servers from it. So you can mix and match and then bundle it and produce what you need for this to work. But there's another approach that David takes that I think is another fundamental ingredient of all of this, and that's understanding where OpenAPI doesn't have the semantics you need, and you need to extend that to get done what you need. And he's got some interesting approaches to that. So I asked him about how he uses OpenAPI extensions.
Sure. Well, I love that. So I actually spoke at one of the earlier API strategy and practice conferences about the tooling that we've done for using extensions and the extensibility. So when OpenAPI came out, the authors there were very, very prescient about this. They knew that we needed the ability to extend the OpenAPI specification to allow for other use cases and other ways of injecting data into the OpenAPI document, because the OpenAPI document as a JSON or a YAML document is itself data, right? It's structured data, and we can process it. And that's been very valuable for us because we have a bunch of custom home-built extensions, and we have an entire tool that sits on top of our OpenAPI pipeline that, as I mentioned before, reads our source OpenAPI that we author in our IDE and in our editing tools, and it will pre-process that source file and create an output OpenAPI document, a generated OpenAPI document that is fully embeddable. And so we extend the OpenAPI specification with lots of different capabilities. For example, one of them is when you define a JSON schema and you have like an enumeration, a type string, and then an enum that has a list of values. And this happens in almost every API, right, where you need to have an enumeration of schemas. So we have like enumeration, for example, within banking, we have enumeration of different types of bank account product types. So it could be a checking account or a savings account or a CD or a money market, and lots of different types. So all those are documented via an enumeration. But within JSON schema, enums are just that. They're just strings. There's no description of what they are and what they mean. And developers can try to put good descriptions, but even if you have a nice, complete, legible, readable description or name for an enum, the description is lacking. So we have a separate specification extension, Apiture enum, that tells us what is the name of this enumeration. And then there's a labels.yaml file that goes alongside the source code that has a name for each of the enumerations, and then a label, which could be an English language label for that enumeration. So it's not just a simple identifier, but it's a full English language label, and a description of each one. And then our tool will process that, and whenever we see an enumeration, we can read those labels and descriptions from that external file and then inject them into the description for that particular schema. So as opposed to just having just a flat list of just enumeration values, we'll have a list of the enumeration values and then an English language label for each one, and then a fuller description of each one and what that value actually means. And that goes into the OpenAPI document that we generate out of our tools. We have bunch of other tools that or things that we generate as well. So we have one that handles deprecation. So rather than just saying deprecated true or false, which is what OpenAPI provides, we have Apiture deprecation in order to deprecate a field or a schema, and we have additional metadata about that deprecation. When the deprecation was first introduced, say version 1.3, when that deprecation is going to be removed, say it's going to be removed on version 2.0 because that's a breaking change. So we go from a 1. Version to a 2. Version. And then we'll have a replacement value to say, okay, if possible, replace the use of this particular feature with something else. So we have a deprecation that says it was deprecated starting on a version, will be removed on a certain version, and here's how to replace it. So that gives us much more richer detail or information about that deprecation and how a developer would use it to update their code to work around that deprecation before it gets removed. So that's a simple schema that goes into our object on each item that gets deprecated, and the tool will generate additional documentation on the description of that operation or that schema to inform the consumer of that information. With each of these types of annotation that we define, this Apiture enum or this Apiture deprecated or a dozen other ones, we also have a JSON schema that describes the data that goes into that particular specification in the document. So as we're processing this source file, if someone mistyped or otherwise had an error in the definition of one of these specifications, we'll just reject that right off the bat. So someone can't get an incorrect value into one of these annotations or extensions within our source file. So we just rely on JSON schema to do that validation, and we provide all the information on how to validate that data and what values are acceptable and what ranges are allowed and things like that. So for example, when you use the deprecation, we'll parse the deprecated since or replace on values to make sure that those are valid semantic version numbers.
David really demonstrates a kind of mastery with JSON schema, with JSON and YAML, but also the schemas for them, and then using them for access to data and using that to manage change over time, as well as all the complexity and everything else we talked about. So it's a really interesting look at how you have to be able to manage your resources and all of your digital objects and assets in a way that is really modular and reusable. And this is how we've been doing APIs. As David said, we've been talking about this for a while, and this is how you do API design. This is how you develop and iterate on your APIs. And it's how you're going to have to make sense of this agentic landscape when it comes to MCP, A2A, agent skills, and other things. These are the tasks. These are the tools. These are the resources that we've been managing for a while. And it's how we're going to be able to express it and create these other context windows for different business outcomes based upon what we need across all of these internal and third-party APIs that we depend on. So anyways, interesting conversation. Hope you like that little bit of a twist. It's one guest, but it really dials in exactly the parts of the conversation that really mattered. So hope you enjoyed it. We'll see you on Thursday, and I think we're going to be talking about event catalog and event-driven infrastructure. So stay tuned.